have really wrapped up all of the stuff that we're doing with derivatives. And for the rest of the year, we are kind of switching gears and going into antiderivatives. So this is the last section in Chapter 4. We're going to cover Chapter 5, which is 5 sections, and then a couple sections out of Chapter 6, and then we're done for the year. So we are getting close. We have spent all this time working on derivatives, and we know a derivative is a rate of change. But sometimes we need to work backwards from that. You know, we have talked about if I have position, I can calculate velocity. But let's say you know the velocity. You might need to know the position at a given point in time. You know the speed something is traveling. You want to know where it's going to be at a given point in time. So that's like an antiderivative. Or if you think about engineers, okay, you know the rate something is leaking. You want to know how much is leaked out over a certain period. Think about if there is an oil tanker that crashes and develops a leak in the ocean. They can measure how fast the oil is leaking out. Would it be useful to know how much oil has leaked at a given point in time? Absolutely. If you know, this is probably really important right now when we're talking about all the coronavirus scare, but if you know the rate at which a bacteria population is increasing, or we know the rate at which this virus is spreading, you want to know what size of the population will be at a certain time, or I want to know how many people are going to be infected at a given point in time. So all of those ideas, if you know the rate, you might want to know how does that translate back to the amount. I know how fast the coronavirus is spreading. I want to know how many people in the United States will be infected at a given point in time. So that is the idea of an antiderivative. Notation-wise, we use F prime for derivative. So a lot of times we will use capital F for an antiderivative. So the antiderivative is just an equation so that if you did its derivative, you got the equation you were starting with. So I want to just give us an example and see if we can come up with an antiderivative. If I said x squared, I want to know what would be the equation so that when I do the derivative of this, I get x squared for my answer. Yes. Why? Yeah. When you do the derivative, you subtract 1 from the powers, right? So when I do the antiderivative, I have to add 1 to it. And when I do this derivative, I'm going to bring the 3 down, and I want to get a 1 out. So 3 times 1/3 will give me 1. Okay, what if I said 1/3 x cubed plus 5? What's its derivative? What if I said 1/3 x cubed minus 20? It's still x squared. So is there only one antiderivative? No. What is the difference? These are identical except for what? The constant. When you do a derivative, the derivative of a constant is 0. So when we're doing the antiderivative, we have to allow for a constant on the end. So to do that, what we are going to do is put a plus c on the end of our antiderivatives. And that c can just represent any constant, any number without a variable. So on all of your antiderivatives that we're going to be doing today, you have to put plus c on the end of every single one of them. Bless you. In thinking about what that means, put this picture on here. If we looked at these, all the constant does is moves the graph up or down. So all of these equations have the same antiderivative. The only difference is the vertical translation. Okay, the slopes of your tangent lines are the same at any given point. So let's start finding antiderivatives. if I said f of x equals sine x, so the antiderivative, we're going to use capital F for that. What has a derivative of sine? Cosine. Okay. But the derivative of cosine is negative sine. So in order to get a positive sign, what do I need to do? Put a negative in front of that. And then what else do we have to put on there? Plus c. That's our answer. B. 1 over x. That's the derivative. 1 over x is x to the negative 1. But if you just add 1 to that power, you get an x to the 0, which is 1, and that doesn't even make sense, does it? What did you say? ln. The derivative of a natural log is 1 over x. So this is ln of x plus c. All right, part C, x to the n. So I just want a generic formula if I have an x to a power. So when you do the derivative, you subtract 1. So when I do an antiderivative, what would I do to my exponent? Plus 1. And when you do the derivative, that exponent comes down, and I need something here to cancel it. So what would it have to be? 1 over n plus 1, the reciprocal of that power. That way when you multiply them, they cancel. And what else do I need? Plus c. Questions about that? This table just has a lot of the common antiderivatives. If we have coefficients, we know, like when we did the derivative, the coefficient just stayed and then we multiplied with it. Same thing when you do the antiderivative, you're just going to keep that coefficient. If you have things added together, you can do their antiderivatives separately. 1 over x is the natural log. E to the x is its own derivative, so the antiderivative of e to the x is still e to the x. Trig functions, hyperbolic functions, I'm not going to give you any of those for antiderivatives. Those were ones that I just gave you the formula when we actually did those in class. So we're just going to keep practicing today. Just like when we did a derivative, we usually would rewrite it without radicals and fractions if we could, just kind of make it easier to think about. So I could write this one as x cubed plus, how would I write as square root of x? 3x to the 1/2 minus 4 over x squared, that would be like 4x to the negative 2. So my antiderivative, we can go term by term. The antiderivative of x cubed you just add 1 to your power, put the reciprocal in front. For the second term, I'm going to show a little more work right now. That 3 is just going to stay. Okay, if I think about my x, you would add 1 to the power. So 1/2 plus 1 is 3/2. And then we always put the reciprocal in front. So what would I put in front? 2/3. I'll clean that up in my next step. But let's go to this one. So if I just keep my 4 for a minute. X to the negative 2. So if you add 1 to your power, you get -1, and if we put the reciprocal in front, reciprocal of -1 is -1. So we get 1/4 x to the 4th. 3 times 2/3 would be a 2x to the 3/2. -4 times -1 is positive 4x to the -1. And what else do we need? Plus c. I would like for you guys to try the next one on your own. So we have x to the 5/2 minus 5x to the -4 minus x to the 1/2 currently. So antiderivative. 5/2 plus 1 is 7/2, so you have to put 2 7s in front. Minus 5, okay. -4 plus 1 is -3, so we put -1/3 in front. 1/2 plus 1 is 3/2, so we put 2/3 in front, and then we need our plus c. So you should get 2 7s x to the 7/2 plus 5/3 x to the -3 minus 2/3 x to the 3/2 plus c. How could you check yourself if you're not sure? Do the derivative of this, and you should get the original every time. It's really quick to check these, especially right now we're doing fairly basic, just adding terms. So if you're not sure if you did it correctly, do the derivative and see if you get your original. Let's do some more. So we have what has a derivative of cosine? Sine. When you do the derivative of a trig function, the angle doesn't change, so this had to be a sine 3t. But let's think about this for a second. If I were to do the derivative of this, I would make it cosine 3t, and then I'd have to do chain rule, times the derivative of 3t, which is 3. So what do I need in front to cancel that 3? Plus 5. What has the derivative of sine? Derivative of cosine is negative sine, so I'm going to put in negative cosine. Now I'd have to do the chain rule, so you would have to take this times 4, so what do I need to cancel it? So 2/3 sine of 3t minus 5/4 cosine of 4t plus c. Is this making sense to you guys? And why don't you just try the next one? So 2 stays. Antiderivative of cosine would be sine of pi x. So you have to put 1 over pi in front. 3 stays. Antiderivative of sine would have to be a negative cosine pi x with a 1 over pi in front. And then plus c. you get 2 over pi sine pi x minus 3 over pi cosine pi x plus c. Look at this one. So we do have to think about the chain rule in reverse. We were doing that on those sines and cosines. We have to do the same thing here. If you were to do the derivative of this, the exponent would come down, the inside stays the same, subtract 1 from the power times the derivative of the inside. So when I do the antiderivative, the inside stays the same. We add 1 to the power, so it's now to the 11. What do I have to put in front? 1 over 11. Now if you're doing this derivative, you would multiply by the derivative of the inside. What's the derivative of the inside? 1. So do I need anything to cancel that? No. And then what else do we need? So this is the same as 3z plus 10 to the negative 7. So if I do the antiderivative, the inside stays the same. Add 1 to the power, so it's negative 6. So what do we have to put in front? Negative 1, 6. Okay, when you do this derivative, you multiply by the derivative of the inside, which is 3. So what else do we need? A 1/3. So negative 1/6 and negative 1/3 gives me negative 1 over 18 times 3z plus 10 to the negative 6 plus c. So I want to find g so that g prime is equal to this. So I'm just asking you to find the antiderivative. I am going to go ahead and rewrite this g prime. Since there's only one term on the denominator, you can divide each of them. So 2x to the 5th divided by x would be 2x to the 4. A square root of x, that's like x to the 1/2 over x. What would that give me? X to the negative 1. So, antiderivative, 4 stays. What's the antiderivative of sine? Negative cosine. Okay, I have my 2. X to the 4th. So that would become an x to the 5th with a 1/5 in front. Minus, okay, my x to the negative 1/2. If I add 1 to my power, that's a 1/2. So what goes in front? 2. And then we have to have our plus c. So do go ahead and clean it up. That's negative 4 cosine x plus 2/5 x to the 5th minus 2x to the 1/2 plus c. don't you guys, actually, can I change this problem? Can I make it more interesting?
Not on there, so.
Yeah.
Oh, it's not on here?
Well, we have like the find f of f prime of x, and then we don't have like the.
Interesting.
So
I'm going to make it f double prime of x is equal to this. And I want f. So how many times do I need to do my antiderivative? Twice. So we're starting at f double prime. So if I go backwards, that would take me to f prime. So 20x to the third. That's 20 times x to the third becomes x to the fourth, so it needs a 1/4. Okay, x squared would be x cubed, so it needs a 1/3. X would become x squared, so it needs a 1/2, and then we put our plus c. So we have 5x to the fourth minus 4x cubed plus 3x squared plus c. Okay. I need the original, so we have to go backwards again. So the x to the fourth would be needs 1/5. Minus 4x cubed would be x to the fourth, so it needs a 1/4. X squared is x cubed, so it needs 1/3. Okay, if you have a constant, when you do the antiderivative, what does it get? It gets an x with it. And then I need another constant. Now I don't want to put another c because do these two numbers have to be the same? No, so let's call it k. Just so we know it's just another number, but it doesn't have to be the same as the first one. So my original function is x to the fifth minus x to the fourth plus x cubed plus some number times x plus a constant. So we can do the antiderivative multiple times. I do not want to do example 10. I'm going to go to example 11. Okay, find f if f double prime is 12x squared plus 6x minus 4, and then I give you some other information. F of 0 equals 4 and f of 1 equals 1. What I want you to do first is find your f prime and your f, just like we did on the last example. So take a second and do those two on your own. Did you guys get those for your first and second? What I have done with these is given you the information to find this c and the k value. When I say f of 0 equals 4, that means if I plug a 0 into this original, so 0 4 is 0, 0 cubed is 0, 2 times 0 is 0, c times 0 is 0. I just get that k is 4. So I now know that my equation looks like this. Then to find my C, I'm going to do the f of 1 equals 1. So if I plug a 1 in for all my x's, I get 1 plus 1 minus 2 plus C plus 4, and that has to equal 1. And we get C to be negative 3. So that is the true original equation with finding all of my constants. Does that one make sense? Let's go ahead and do one more, then we'll stop. Sometimes you might hear this called an initial value problem. I'm asking for the same thing. I've given you f prime, and I've given you some characteristic about f. So what I'm asking you to do is find the antiderivative. And because I've given you this piece, we're going to be able to find our constant. So our antiderivative, x to the fourth become x to the fifth, so it needs a 1/5. X becomes x squared, so it gets a 1/2. 3 over x cubed, that's like x to the negative 3. So if you add 1, it's negative 4. So it's a negative 1/4 in front, plus c. Hold on. I subtracted 1 from my power, didn't I? Negative 3 plus 1 is negative 2. So this should be a negative 1/2. And so now how do I find my C? Plug in my 1. So to be 1/5 minus 3/2 minus 3/2 plus C, and it has to equal a negative 1. So if you do your 1/5 minus 3/2 minus 3/2, negative 14 over 5 plus c equals negative 1. Add your 14/5 over, and you get a positive 9/5. So my original equation is 1/5 x to the 5th minus 3/2 x squared minus 3/2 x to the negative 2 plus 9/5. I'm going to finish this section tomorrow. I tried to get as far as I could because I know some of you won't be here tomorrow, so I was trying to give you as much as I could. You can watch the video. Really, all we're doing tomorrow is more of the same, but we're just talking about it in terms of velocity, acceleration, position, those. So technically you know how to do everything at this point, but we will do examples involving position, velocity, and acceleration tomorrow. So the homework, I'm just going to go ahead and put it all up here. It will all be due Tuesday because we don't have school Monday. So that means tomorrow I will finish the section, and then whatever time I have left, you will get to work on it. And then whatever you don't get done, you need to have ready on Tuesday.